I tested two vision language models on real aerial farm imagery to see where the current generation actually lands on a job like this. 14 photographs, the same prompt for both, character for character. One model runs entirely offline on a 4 GB laptop GPU. The other is an API call that cost about 2 cents for the whole run. They agreed on the easy frames, and where they split apart turned out to be more useful than the score. On the left, Gemma3 4 billion parameters 4-bit quantized, running entirely offline on a 4 GB laptop GPU, 16 seconds per image. On the right, Gemini-3.6-flash over an API, 5 seconds per image, and about 2 cents for the whole run of 14.
The prompt asks for 4 things. Is this usable and from what viewpoint? Which way do the rows run? What parcels can you see? And is there any stressed vegetation and where? It ends with, do not invent findings. Remember that line.
9 images are genuine drone frames over farmland. 2 contain real crop damage, and 4 are traps, although, as you will see, I only knew about 3 of them when I started.
Start with an easy one, a straight-down frame over drilled rows. Both models get it. Usable, nadir, regular rows, parcels split by a tree-lined road. On clean imagery, there is very little between them.
Here is the first crack. The rows in this frame change direction between the top and the middle. The small model says parallel, regular. The big one says vertical in the top section, horizontal below, with a separate strip at the bottom. Same picture. One of them is reading it. Now the small model breaks. This is a straight-down frame, and it calls it oblique. Look at the anomaly line as well. It has started repeating my own prompt wording back at me as though it were an observation. Gemini reads the field correctly, including the diagonal parcel in the bottom right corner. Maize, with clear gaps in the canopy. The small model reports stressed vegetation, top left. The big model reports large missing crop patches in the top right field and along the lower edge. One of those is a location. The other is a habit.
This is the frame I want to be honest about. There are 3 things here: a harvested stubble field at the top, a maize field, and a vegetable plot in the middle right. Gemma flattens all of it into green vegetation across the entire frame. Gemini splits it into exactly those 3 zones and points at the vegetable plot. And when I went back to check, my own written label for that image was wrong too. I had called it stress in a dry crop. It is an allotment next to maize. The frontier model described the picture more accurately than my notes did. Same again here. A near-uniform maize canopy with small, dark, damaged patches. Gemma says top left. Gemini says small circular patches of flattened vegetation, lower center and lower right. I opened the full resolution image to settle it. The patches are lower center and lower right. Then this one, which is the reason I am recutting this video. I had it in my set as a nursery, discrete blocks of plants, the closest thing I had to a research trial layout. Gemma called it usable and nadir. Gemini called it unusable and oblique. Gemini is right. Look at the farmhouse and the barn. You can see their walls, and the perspective converges toward the top of the frame. This is an oblique shot. It is a 4th trap, and I had not noticed, which means my scoring had credited the small model with a correct answer it never gave. That is worth sitting with for a second. The ground truth in an evaluation is also a model. It is a model that lives in your head, and it is also wrong sometimes. If the only thing checking it is you will score your errors as somebody else's. Back to the sweep. Another straight-down frame the small model calls oblique. 3 fields, a dirt path, a vegetated ditch, all of which the big model lists, and none of which the small one does. A tree line splitting a bright green field from a harvested one. Gemma, slight discoloration upper left zone. Gemini, yellowing foliage on the tree at the left end of the line. and thin patches along the tracks, specific enough that you could go and check it. Now a satellite-scale image, a whole regional grid of parcels. Individual crop rows are physically not resolvable at this scale. Gemma reports rows running north to south with regular spacing. Gemini answers, rows, none, and rejects the image as not a crop field. Stricter than my own label, and I think correct.
Converging rows against a hard boundary. Both models handle it. 3 parcels, dirt tracks. The small model adds stressed vegetation in the top left corner. By now, you can predict that sentence before it appears.
Trap 1. An oblique photograph of urban sprawl taken from an aircraft. Houses, streets, a sports field. Gemma calls it usable, nadir, with crop rows running east to west. There are no crop rows. Gemini calls it unusable and oblique, and reports nothing else, because there is nothing else. Trap 2. The engraving. Gemma accepts it and reports stressed vegetation at the top of the rock pile. Gemini answers, unusable, not aerial. Not merely a rejection, the exactly correct category out of 4 it was offered.
Trap 3. A cassava leaf photographed from about a meter away. Gemma, usable, nadir, rows running horizontally. Gemini rejects it as ground level, and then, unprompted, reports yellow mosaic chlorosis and leaf distortion across the frame. That is consistent with cassava mosaic disease. It was right to throw the image out, and it still read the plant.
So, the numbers. Hard negatives rejected 0 out of 4 against 4 out of 4. Viewpoint correct 8 out of 14 against 14 out of 14. And the anomaly line. The small model claimed a finding in 12 of 14 images, despite being told not to invent findings, and 9 of those 12 landed in either the top left or the bottom right corner. The big model claimed 6 and clustered in no corner at all.
One finding does not transfer, and I want to flag it rather than quietly drop it. On the small model, writing the same prompt on 1 line instead of 4 made it stop answering and start printing my template back at me, options and all. A parser reading the first token would have logged a decision the model never made. I have not run that same test against Gemini, so I am making no claim about it either way.
Here is what actually changed my mind. I built this expecting to conclude that vision language models are not ready to gate agricultural imagery. That conclusion was wrong. The task was fine. The 4 billion parameter model was the problem. And a working gate costs about 0.2 of a cent per image, and 5 seconds.
Which moves the real question somewhere more useful. Not can a model do this, but which model, at what cost per frame, checked how. Description is not a decision, and the gap between those two things is still where all the engineering lives. One note on the pictures. All 14 come from Wikimedia Commons, reused under Creative Commons Attribution Share-alike and public domain licenses. Full credit is on screen here and in the description.